In early 2007, something moved nearly 2,000 miles beneath the surface of our planet, and nobody on Earth felt it happen. No earthquakes, no warning, no headline. Just a silent shift buried so deep inside the planet that it took satellites years to even notice something had changed. But when scientists finally pieced together what actually occurred, they found the signal centered, directly over the eastern Atlantic Ocean, right beside the British Isles, closer to the United Kingdom than almost anywhere else on the map. And now, years later, researchers are confirming something that should genuinely unsettle you. The deep interior of our planet is rearranging itself in ways we never knew were even possible, and the region around Britain appears to be sitting closer to the epicenter of these changes than anywhere else on Earth. To understand why this discovery matters so much, you first need to understand just how strange it is to detect anything happening nearly 2,000 miles below your feet. We cannot drill down there. We cannot send a camera. The deepest hole humans have ever dug barely scratches 7 miles into the crust, a fraction of a percent of the distance to the core. So when scientists want to study what is actually happening in the deep interior of our planet, they have to rely on incredibly subtle, indirect clues, tiny fingerprints left behind by processes happening thousands of miles beneath the ground we walk on every single day. That is exactly where satellites come in. Starting in 2002, NASA and the German Space Agency launched a pair of twin satellites called GRACE, designed to fly information around the entire planet while measuring gravity with extraordinary precision. Here's the clever part. When one satellite passes over a region with slightly stronger gravity, caused by extra mass concentrated beneath the surface, it speeds up just a tiny bit before its twin catches up. That barely detectable stretch and squeeze between the two satellites let scientists build incredibly detailed maps of gravity changes across the entire globe. Maps originally meant to track groundwater and melting ice sheets. But buried inside nearly 2 decades of this satellite data, a research team led by a scientist at a university in Paris found something nobody was expecting. Between 2006 and 2008, an enormous gravitational anomaly emerged across the eastern Atlantic, an area stretching more than 4,000 miles wide, peaking dramatically in January of 2007 before slowly fading away. One band of the anomaly pulled slightly harder than slightly weaker, exactly the kind of pattern you would expect if a massive amount of material had shifted from one location to another deep underground. Naturally, the first explanation scientists reached for was water. Oceans hold an almost unimaginable amount of mass, and shifting water alone can easily create gravity changes strong enough for satellites to detect. So the team carefully compared the anomaly against detailed hydrological models, simulating exactly how water moves through ocean basins during any given year. The timing simply did not match. They checked ocean temperature readings. They checked salinity levels. They checked sea level data from the exact region and time period in question. None of it lined up. Whatever caused this signal would have required an impossible amount of water gathering in precisely the wrong place at precisely the wrong time, which meant the explanation had to come from somewhere else entirely. That is when attention turned downward, thousands of miles beneath the ocean floor, toward the boundary where Earth's solid rocky mantle meets its liquid metal core. This region sits roughly 1,800 miles below the surface, in a mysterious zone scientists call the D double prime layer, one of the strangest and least understood regions inside our entire planet. Temperatures here swing dramatically from one patch to another, and pressure reaches levels almost impossible to imagine, thousands of times greater than what you feel standing on the surface right now. Deep inside this layer sits a mineral called bridgmanite, the most abundant material in Earth's entire lower mantle, even though virtually nobody has ever seen a piece of it because it can only exist stable under these crushing extreme conditions. Under intense enough heat and pressure, bridgmanite can actually transform, its atoms rearranging into an entirely different, denser structure called post-perovskite. When that transformation happens across a wide enough area, it can shift a genuinely staggering amount of mass from one place to another, exactly the kind of event that could explain gravity readings shifting the way satellites recorded them over the eastern Atlantic. Here is where the story gets even stranger. Almost exactly when this gravitational anomaly peaked, a completely different set of satellites, ones built to monitor Earth's magnetic field, recorded a sudden and unusual shift over the same general region of the Atlantic. Scientists have a specific term for this kind of event. They call it a geomagnetic jerk, a sudden and unexpected change in the long-term direction of Earth's magnetic field. These jerks are believed to be triggered by shifting flows of liquid iron churning within Earth's outer core, since that flowing molten metal is exactly what generates the electric currents responsible for our planet's magnetic field in the first place. 2 completely different satellite systems, monitoring 2 completely different physical properties of our planet, both detected something unusual happening in the same region, at nearly the same moment in time. Researchers have been careful to point out that this overlap does not prove one event directly caused the other. But finding both signals lined up this closely is exactly the kind of coincidence that makes scientists sit up and take notice, because it hints that something much larger and more fundamental might be happening deep inside our planet's core. If a discovery like this genuinely fascinates you, go ahead and hit that subscribe button right now, because understanding what is happening beneath our feet might matter more than most people realize, and we are just getting to the part that actually concerns Britain directly. Here is why this particular discovery lands so close to home for anyone in the United Kingdom. The anomaly researchers identified was not spread evenly around the globe. It was concentrated specifically over the eastern Atlantic Ocean, the exact stretch of water sitting directly beside the British Isles. Britain does not sit at the center of the planet's tectonic action, the way places like Japan or Indonesia do. Yet this particular deep Earth signal happened to emerge almost directly off its coastline, making the UK geographically closer to this mysterious deep interior event than nearly anywhere else on the map. Scientists studying our planet's magnetic field have long known that Britain occupies an unusually sensitive position for detecting these deep changes. The magnetic field is not uniform across the globe. It weakens and strengthens unevenly depending on what liquid iron is doing, thousands of miles below different regions of the planet at any given moment. When a geomagnetic jerk occurs, monitoring stations positioned across Europe, including several across the United Kingdom, are often among the very first instruments on Earth to register the shift, simply because of how the magnetic field lines happen to be oriented in that part of the world. This is not some abstract scientific curiosity locked away in a laboratory. Earth's magnetic field genuinely matters for everyday technology. It affects compass accuracy used in navigation systems. It affects the orientation data used by ships, aircraft, and increasingly autonomous vehicles. It even factors into how power grids handle sudden fluctuations during periods of unusual magnetic activity. A region experiencing an unexpected magnetic jerk sits closer to first-hand disruption than areas farther from the source, and researchers have noted that the United Kingdom's geographic and magnetic positioning puts it in a genuinely front-row seat for monitoring exactly these kinds of deep Earth events as they unfold. What makes this discovery even more remarkable is how quickly the change appears to have happened. Scientists studying deep Earth processes are used to thinking in terms of millions of years, tectonic plates creeping along at roughly the speed your fingernails grow. But this anomaly built up and faded away within a span of just a couple of years, an almost impossibly fast timescale for something happening nearly 2,000 miles underground. If a broad region of mantle rock genuinely crossed a mineral stability threshold that quickly, it suggests our planet's interior can rearrange itself far more rapidly than most geologists ever assumed possible. The scientist who led this research has been careful and measured about the conclusions, noting plainly that at least part of this signal has to originate from somewhere within the solid Earth itself, since surface water and core fluid flows alone could not fully account for what the satellites recorded. That kind of cautious, deliberate language matters in serious science, but do not let the careful tone fool you into thinking this discovery is minor. Confirming that mass can redistribute this dramatically, this deep inside our planet, on a timescale of mere years rather than millennia, fundamentally challenges assumptions that have shaped geology textbooks for generations. Researchers are now hoping to use a newer generation of satellites, successors to the original GRACE mission, to hunt for more events like this one happening in real time, rather than reconstructing them years after the fact from archived data. Finding even a handful of similar deep Earth rearrangements would help scientists understand whether what happened over the eastern Atlantic in 2007 was a rare, one-time fluke, or the first clearly documented example of something that has actually been happening deep inside our planet all along, invisible to us simply because we never had the tools sensitive enough to catch it happening before now. It is worth remembering that this is not the only strange signal scientists have picked up from deep inside our planet in recent years. Separate research teams studying Earth's inner core, that solid ball of iron and nickel sitting nearly 3,000 miles down, have found evidence that it is not behaving the way textbooks always described either. Its rotation speed appears to be shifting, its shape seems to be subtly changing, and in some studies its very surface near the boundary with the liquid outer core appears to be deforming in ways nobody predicted. Separately, geophysicists studying seismic waves have mapped entirely new categories of earthquakes rumbling far deeper inside the mantle than anyone believed was physically possible, clustering in unexpected regions around the globe. None of these discoveries were made in isolation. Together, they paint a picture of a planet whose interior is far more restless and dynamic than the calm, static diagrams found in old science textbooks ever suggested. What ties all of this back to Britain is not just geography, it is timing. As monitoring networks across Europe continue expanding, and as newer satellite missions gather sharper gravity and magnetic data with every passing year, Instruments positioned across the United Kingdom are increasingly likely to be among the first to register whatever comes next from this restless region of the Eastern Atlantic. Scientists studying the 2007 event have openly stated that one detection cannot prove how often these deep mass shifts actually occur. It could be an exceedingly rare event, or it could be something happening quietly every few decades, simply going unnoticed until satellite technology became sensitive enough to catch it. For now, the people living across Britain and the surrounding region go about their daily lives with absolutely no sense that anything unusual occurred nearly 2,000 miles beneath their homes. No tremors were felt, no warnings were issued. Life simply continued exactly as normal, but somewhere far below the Atlantic seafloor, deep inside a layer of our planet hotter and more crushing than almost anywhere else, something shifted in a way scientists are still struggling to fully explain, and the instruments closest to catching the very next signal happen to be sitting right there in the United Kingdom, quietly listening for whatever the deep Earth decides to do next. If this story changed the way you think about the ground beneath your own feet, make sure you like this video and subscribe, because we dig into the hidden science shaping our planet that most people never even hear about. What scientists just confirmed about our planet's interior is genuinely one of the strangest discoveries in recent geology, and it is proof that even after centuries of studying Earth, we are still only beginning to understand what is actually happening beneath us. Stay curious, stay informed, and I will see you in the next one.